Hello everyone, and welcome back to another video. My name is Jamil, and today I'm going to be taking you through another LeetCode. Thank you for joining me here today. Today's problem is LeetCode number 1021, remove the outermost parentheses. So if you've been to my channel before, you'll know that we've attempted a parentheses question before, and we used a simple trick for depth in it. And what I'll be doing is I'll be taking that method and trying to redo that here today with this new question because it does build off of the same fundamentals. So if you're unfamiliar with it, I will link that video somewhere in the description below, and I recommend you go check it out because it is, another explanation if you're confused by this video. So without further ado, let's get into reading the question. So a valid parenthesis string is empty, okay? Or you have a left parentheses plus a string plus a right parentheses, or two strings concatenated with each other, where A and B are valid parentheses strings that represent each string concatenation, okay? So for example, we have an empty string, a string with two parentheses, and a string with a couple of parentheses and some more, okay? And these are all valid parentheses strings. Hope that's all makes sense so far. It doesn't look like it's too complicated. You just have a right and a left parentheses, and those create a pair. Ultimately, what we're looking for is the very outermost pair of every pair, and remove that. Okay? So a valid parentheses string S is primitive if it's non-empty, and there does not exist a way to split S to split it into S is equal to A plus B, with A and B non-empty valid parentheses strings. So given a valid parentheses string S, consider its primitive decomposition, which is S is equal to P1 plus P2, so on and so forth, all the way up to P of K, where Pi are primitive valid parentheses strings. So there's a lot happening here, and these words are very big and confusing. So just stick with me here for a moment, and I'll try to explain it to you quickly in our example. So essentially what we're looking for is we're going to return S after removing the outermost parentheses of every primitive string in the primitive decomposition of S. Okay? So we have S here with multiple parentheses, both left and right, and an output of 3 closed parentheses. So how did we get here? Okay? So the input string is this, obviously, which is S, but with this primitive decomposition of when we go back to A and B, right? When you say S is the sum of all of the parts of your string, you can break down this input here into this set of parentheses, right? So you have one large outer parentheses containing 2 smaller inner parentheses, okay? And then one large outer parentheses here and one inner parenthesis. And so when you remove both of these outer parentheses, you end up with 2 parentheses and 2 parentheses, and when you concatenate them together, you get your string S again, right? And you'll get 3 regular parentheses. Similar idea here. At the very on example number 2, you're past a bunch of parentheses. You're supposed to try and find the outermost parentheses in all of these sets of parentheses. But you will see here the output at the end has a set of nested parentheses, and that is because if you take a look here, right here, okay, you have outer parentheses. So the input string is this with a primitive decomposition of your this first set of parentheses, then this second set of parentheses, and then this third set of parentheses, right? So I think this answer here is missing something. No, I just skipped over the step. I went over one line too far, but you'll see here that you have this and this parentheses representing the outside, and then this is all of the inside, and we just need to return what is in the inside, which is this guy right here. And when we concatenate all of this together, we end up with our output string, which is this. So that's essentially what we need to recreate. We need to try and recreate that in the form of a function. So let's get started then. I won't be going over the constraints too much. It's just basically we're either we're past, you know, left and right parentheses, it's a valid string, and then you can go up to 10,000 characters in length. So we have to be able to take that all into account. All right. So let's start figuring out what we are being passed. So we are passed a string. Okay. The string is a valid parentheses string, which means there will always be at least one set of outermost parentheses. Okay? These parentheses can be nested. So we can have multiple sets, and we just need to get rid of the very most outer layer set. Okay? So the goal here is to figure out, find all outermost parentheses and to remove them. And so what are we returning? Return the new string after every outermost parentheses has been removed. Do not mutate the string, do not change the order of the string. Okay, because we need to return it in its original order. We just need to be able to remove the outermost parentheses. Okay, fantastic. So let's take a look at this. We're going to need two variables. All right. So first, what we're going to do is we're going to need a variable. A variable to hold what? Our depth. Okay, because the trick is similar to the way that we did it before, is that every time we open up a set of parentheses, we will step into one set of parentheses, and basically we are one depth deeper. Okay, so let depth, which is a number, equal to 0. And then, since you cannot mutate strings in JavaScript without doing a bunch of work on them to change them into an array, work on them, and then return them back to a string, what I'm going to do for this example is I'm just going to simply create an answer, which is a string, and it's going to be just an empty string, and I'm going to concatenate. So I'm going to pass into my answer every valid set of parentheses that I am looking for. Okay. Control and enter apparently runs your program, and I'm not trying to do that. So let's just try to do this here, and we are going to say create a variable to hold your valid parentheses without mutating your original string. Okay, perfect. So now that we have a string that we need to iterate over, you know, and to find the valid parentheses, this is what we need to do. We need to create a for loop that I equals to 0, right? Which is also, happens to be a number. And I is less than the string, the length of the string, and then I++, so that we can count up, right? So that we can iterate over our string. So what do we need to do when we are trying to find our valid parentheses? So we need to take account of two things, right? We need to know if we are first iterating over a left or a right parentheses, and if we are iterating over a left, like an opening bracket, basically, we need to add to the depth. And then if our depth is not 0, so we are inside of a valid set of parentheses, we are going to start concatenating. But then when we close, we need to step out of our depth, and then we make a check. And in our check, we will see if depth is not 0, then we haven't completely stepped out of all of our outermost parentheses, and we need to keep adding to our string. Okay, perfect. So since we are already iterating, now we need to just do our check, right? Check to see which bracket, I'm going to call it, or parentheses for the sake of which set of we are on, which set of parentheses we are on, and if we have any depth. Because if we have any depth, then we need to add we need to concatenate to our string. Okay, so we'll start this. We'll say here, and we'll do this. And it says if s of I, so if the current element is equal to this, right? What are we doing? I need to, yeah, okay. Now we need to do our check. So if there is a depth, right? So we're going to say answer plus equals to s of I. Okay, so first we need to check our set of parentheses, which is s of I, and then we need to see if we have any depth. So if depth, answer plus equals to I. All right, so why do we do that? And so if also we need to double check, we need to add to our depth in here. So we need to say depth plus equals 1. Okay, so what are we doing from lines 14 to 8 to 19? We have checked to see if which set of parentheses we are on. So we have told it if we are opening our brackets, okay, and then we have a depth, because some, like, if you are checking in our input here, right on the left hand side, at the very left hand side here on example 1, when we iterate over our first bracket, right, s of I is equal to the left bracket, is there a depth, right? There is no depth. We haven't stepped into any, we're at this point right here, right? We haven't stepped into any parentheses. So do we do any addition to the answer? We don't, because this is technically our very outermost set of parentheses. We can tell that based on the logic that we have built here. Okay, but since we know we are at the, like, we are on a left bracket, we have stepped into a depth. We always need to know if we need to add to our depth. So by the time we get to the second parentheses here, this triggers because depth is now greater than 1. And as long as depth is greater than 1, or sorry, greater than 0, not greater than 1, my apologies. As long as depth is greater than 0, it is a truthy value. Okay, I'm just going to say here, this is a truthy value check. Okay, because when depth is equal to 0, it is a falsy value. And if you're unfamiliar with truthy and falsy values, I would suggest you take a look at that in JavaScript to understand what that means, because you will see checks like this, right? So if depth comes back as anything that isn't 0 or null or undefined, right, then it is not a falsy value. That means it's truthy. There is a value assigned to the variable that isn't anything that I just mentioned, and so we know that, like, this check will pass. Perfect. So now what we can do else is we need to check for the other one, right? So we'll do the same set of thinking here. So I'm just going to copy this here for the sake of simplicity and paste this right in here. And I'm going to put my second set of parentheses. Now we need to do the opposite, okay? We have stepped out of a parentheses, right? We have closed our brackets. Since we have closed our brackets, we need to take away one of our depth values, okay? Then we run our check. If depth again, right? Then just, it's the same condition, right? First, you'll check the depth when you're opening it, and then you add to it. Then when you're leaving, you take away from the depth, and then you determine if you're still within a nested set of parentheses, and you add to your final answer. And then once that's done, okay, you can just return the new string, okay? Not s, but answer. And this will satisfy that right there, because the function is expecting a return of a string. And answer, we assign it as a string, an empty string, and then we concatenate it over it on lines 16 and 22. Let's double check and see here. Does this work? Perfect. Look at that. Our output is 3 sets of parentheses, just like our expected output. Okay? In this next test case, same thing. It does the same exact thing. All right? So, essentially, what we need to do is we just need to be familiar with this logic here in order for us to run our check. and understand what we are doing. So when we are opening brackets, we need to double check and see that we haven't already opened a bracket beforehand. And then when we are closing brackets, we need to double check and make sure that we still don't have any more brackets to close. Okay? And when you do that, when you play around with this, and when you get comfortable with this idea, you will see what I mean by depth. And basically, I hope you can understand that, like, it's almost like you're taking a step. Like, just think of taking a step further down, like like your sea levels, right? And then you're taking a step back up. If you are at ground zero, right, and you've stepped down one level, right? Have you stepped down 2 levels? You have to work your way up back to level 1 before you can work your way back up to level 0. Okay? And that's all there is to depth. Anyways, let's see if we can submit this and if this comes back with a proper answer. Oh, or if it satisfies our solution. Perfect. We have a compile error, but that was because I pressed Control and Enter before. But here we are. This solution works. If you learned something here today, please make sure to like the video and let me know in the comments below. If this was something helpful and you would like to see more, I have a full playlist of LeetCode videos that you can take a look at and reference. But once again, my name is Jamil. Thank you very much for joining me here today, and I'll see you next video.